All right. I think this is going to segue pretty well into the two presentations we just had, but essentially where I want to start is discussing at the beginning of 2020, we released our next generation compliance tools. For those of you that don't know what a compliance tool is, it is a tool that mounts on the end of your robot to give a robot more of a human touch. So essentially it is a constant force device with a linear slide on it. Smaller unit has 20 millimeters of stroke. Larger unit has 40 millimeters of stroke. What I want to touch on for this discussion was that we've extended the communication protocols. So incorporating our equipment into advanced projects, much like Lou and Daniel just described, you can do that now with the compliance device, and we give you full control of the unit. We've also added passive POE communication to the platform, which will allow you to remove the FCU controller from the equation and talk directly to the compliance device, simplifying the hardware architecture. So with this extended available communication protocols, we have a web request, a UDP, TCP/IP, USB, field bus, as well as digital IO if you keep the FCU in the equation. So looking at that, traditional communication has been robot to the FCU to the compliance device. Keeping this available, new for this year is the field bus. So now with the field bus, Profinet, Ethernet IP, and DeviceNet are available. And because we're using HMS AnyBus, M40 CompactCom, any of the other field bus should be available as well that card supports. We just haven't had an opportunity to test those yet. So that being said, this is a great platform if you're using more of a traditional off-the-shelf robot or PLC. But if you're going with a stripped down version, similar to what was described earlier, you can introduce this passive POE device. And through the passive POE, you can do the web request, the UDP, or the TCP/IP communication directly to the PushCorp compliance device itself. So here's an example of a web request. You can see just right through our Chrome browser, we communicate back and forth. This is a JSON-based structure here, so you can do JSON parsing to pull out the data that you're looking for and then use that in your program. So in the first example, we're just getting the state object. So essentially it's telling you what state is the controller in, and it's giving you all the information back. In the second example, in the middle of the screen, we're setting the force to 20 pounds or newtons, depending on if the system is set to metric or English. And then on the bottom one, we're asking it what it's set to, and it's replying back that I'm set to 20 units, if you will. With the TCP or USB request, I just did a simple connection to PuTTY through the unit, communicating through port 23, and there again, you can if the FCU is still in the equation, you can talk to the FCU, or you can talk through the FCU to the AFD. And same thing again, I commanded the force to 20, and then I asked it, what force are you commanding? It told me 20. I changed it to 50. It said okay, and then I confirmed that we're again going to 50. So I am going to try to change here to. So here in the manual, hopefully everybody can see the manual there. For some reason, it's not letting me see what I'm presenting, so I'm hoping you guys are seeing the manual there. We give you access to everything within the AFD. So to be able to embed this into a high-level structure, you can build your own GUI, your own interface, to be able to control all the force control parameters within your system. All of this is available on our website today. There's no extra charge, no anything. So anybody who currently has one of the next generation AFDs, you can start using this all today. And using this method also gives you a lot more access than what's available through the field bus or the digital IO interfaces. So and with that, I'm going to pass it on to Eddie, who is going to talk about some of the new or I'm sorry, I should go back and ask if anybody has any questions there. No questions? I can't. All right, then I will pass it on to Eddie here, who will discuss the new products that are coming out for 2021.
How's it going, everybody? Thanks for having us on today. My name is Eddie Erlbacher. I'm one of the mechanical engineers here at PushCorp. So today, just wanted to talk about what's new for 2021 and some of the products that are in development right now that we're excited to release and to talk about with you today. With the growing popularity of cobots and smaller industrial robots, we had to sort of rethink our products and our product offering. And so we went back to the drawing board and really tried to figure out how we could optimize the products that we already have, trim some of the fat, use different components to get these components as small as possible and as lightweight as possible, which you can see sort of conceptual of what we've come up with so far. These products, both the spindle and the force compliance device, have been totally revamped. The force compliance device will be able to use the same control schemes that Max described earlier in the slides. And so this tool will be an active compliance device, meaning it will compensate for gravity as you change orientations and will vary the amount of air pressure being applied. So no matter what orientation you're in, you'll be able to maintain a constant force for material removal applications and other constant force applications. So yeah, again, this will work with the FCU for the digital IO or the field bus protocols, as well as the passive POE. So the force compliance device will apply a constant force. And so right now, this has a maximum force capacity of 27 pounds. And so we sort of came up with this number based on a lot of the testing we've done here in our lab. So we do a lot of proof of concepts here in Dallas, where we test out customers' parts from grinding, sanding, deburring, polishing, various material removal applications. And so what we found is for virtually all sanding applications on composites, steel, aluminum, you're never applying, I guess I should say, in most cases, you're not applying more than 25 pounds of force. The same goes with sanding aluminum or grinding aluminum. Most cases, again, you're not applying that much more force than that. And then even some steel, as far as if you have a very light weld that you're trying to remove, again, you don't have to apply that much force. So that's sort of where we came up with that number. As far as the spindle, this is our SM2002. It's a 20,000 RPM, 2 horsepower motor. And we've actually had this product for a little while, but we're completely changing how the internal components, as well as some of the manufacturing components. And basically, we see these two products as a higher volume system because of this popularity with the cobots and the smaller industrial robots. So we want to make it as easy to manufacture, to assemble, while still giving a the high quality system that our customers have come to know. So this version will be a manual tool changing, or a manual collet version to start. It'll be an ER style collet like our other motors. And then we will also be implementing a new servo amplifier. We've historically used a Kollmorgen S700 with all of our spindles, but Kollmorgen has a newer AKD drive, and which is a little more friendly with the field bus protocols, Ethernet IP. And so again, just trying to make this as easy as possible to integrate and to use with these smaller robots. So here's a side-by-side comparison. On the left is one of our current models. It's the AFD 310, which was on the first slide that Max showed, as well as one of our current manual collet motors. This system weighs roughly 15 kilograms, and you can see is fairly large for that small robot. So on the right, again, just trying to get that as small of a package as possible. And I don't have a weight to share with you today, but the next two slides show just, I guess, how much of a percent change. If you go to the next slide, Max. Shows the percent reduction that we're expecting. So just trying to trim that down as much as possible. And as you can see, we've done a fairly good job of that so far. So that, I guess I didn't mention that, but it'll have a 0.6 inches of travel from the positive to the negative tick marks that you can see on the carriage. And again, 27 pounds of force. And then if you go to the next slide, Max, you can see the percent reduction, and this is comparing our current manual collet spindle with this new version. So with that said, I guess if there's any questions about this equipment or about the controls that Max discussed, feel free to ask.
So no yet on kind of like kind of what class of payload cobot are you targeting?
I mean, we would like to be as small as possible. I mean, we haven't finalized our design, but I mean, we would love to be on a 10 or 15 kilogram robot. Whether that's feasible, we're still sort of in this development stage, but again, we'd like to get it as small as possible, just to try and be able to get on those cobots.
The other thing, Matt, that we've been discussing and kicking around is mounting the smaller compliance device with like a gripper for small assembly type projects. So having that force control for being able to snap things together, where it would just be the compliance device without the spindle, something much smaller, much lighter, and give you that closed loop feedback and be able to change that on the fly is something else we've been discussing.
Oh, okay, interesting. Is the goal, I mean, have you been doing some work in sort of reach analysis? It looks like obviously how you've changed how the spindle is sort of like encapsulated in the entire tool, right? I mean, have you been looking at like getting into tighter spaces? Is that some of the driver for kind of the nature of how this design has come together? Not just like reducing weight?
Yeah, I mean, definitely. I think our biggest factor has mainly been the weight to be able to even get into these, to be able to mount onto these smaller robots. With our tool changer or with the ER style collet, we do allow, it allows the customer to build longer tool holders for reach. And so we've seen that quite a bit on our current generation, where customers will build, 8-inch mandrels with an abrasive disc on the end to get into tighter spaces. So that's historically has been accounted for in the tool holding or the tool holder, because we want to keep, our entire package as small as possible for customers that don't need that reach. So yeah, historically that's accounted for in the tool holder.
Right. No, yeah, great. And I've seen some application videos where, yeah, with the long tool holders too, right? So no, thank you. All right, Max and Eddie, thank you for sharing the latest updates. We're looking forward to kind of see these products get out there. So